Hey Trig students, we're going to be looking at sections 5.5 and 5.6. There are going to be several identities in this section, and here's two of them named right here, double angle identities and half angle identities. But we'll also be looking at something called a product to sum and sum to product identities. We just touch base with those. We don't do too much with those. And even your problems will even ask you, find something using the product to sum identity or sum to product identities. And it specifically states that in the problem normally. But let's go on and look at some double angle identities to start us off. All right, so before I just throw the identities at you, I want to show you how you can come up with one of these at least, the cosine double angle identity. Well, the cosine of 2a, that's what it means by double angle, is 2 times your angle, is equal to this right here. Well, we've used the cosine sum identity before. We've solved things that have cosine of a plus b, but we can say 2a is the same thing as a plus a. All right, using the cosine sum identity, we plug in our angles a into our sum identity. And what we end up with when we multiply cosine A and cosine A is cosine squared A. And then same goes with sine A and sine A. Multiply those together, we get sine squared A. So this right here is one of our cosine double angle identities, is that right there. But there are a couple other ways we can write this double angle identity. Let's take a look at those. So here I just have what was typed out on the previous page. This is one of our double angle identities for cosine. Now another one is if we replace cosine squared A with 1 minus sine squared A, which comes from the Pythagorean identity, we should know by now that cosine squared of an angle is equal to 1 minus sine squared of the same angle. Okay, and whenever we when we replace cosine squared A with the 1 minus sine squared A, we end up with another cosine double angle identity as this right here. And it's often nice to have uh, these multiple identities for cosine of 2a, or a double angle identity for a cosine, because many times you're not given both cosine and sine values. Sometimes you're just given one or the other. And so uh, in case an example like I'm going to show you here in a little bit, in case you were just given sine A, well, we can find cosine of 2a by just using this double angle identity rather than finding cosine of A and going through that process and having to find. It's a shortcut. That's all it is. Okay, now there's one other. Now, back again at this first identity of the double angle for cosine that we looked at. We also should know that we can replace sine squared A with, again, using the Pythagorean identity, with 1 minus cosine squared A. And this gets us this one, 2 cosine squared A minus 1. So again, if we're looking for a cosine of 2a value, and the only thing we are given from the beginning of the problem is a cosine value, well, use this identity rather than this one or this one. Okay, so let's take another look at some more identities. All right, so we looked at these. These are all of our cosine double angle identities. Sine and tangent only have one identity, so it's pretty straightforward. You have to have sine, you have to have cosine, these two values, in order to use this to find the double angle. Okay, and then same thing goes with tangent. Now I will say, if you know what sine of 2a is and cosine of 2a, then finding tangent of 2a, you can use this fact, that sine over cosine is equal to tangent. So if your problem states to find what cosine of 2a is equal to and then sine of 2a is equal to, well, divide those two numbers after you find them and you've got tangent of 2a. All right, so let's look at our first example here. So we're given some information and then asked to find three other things. So we're asked to find sine of 2 theta, cosine of 2 theta, and tangent of 2 theta, only given that sine of theta is equal to 8 over 17, and we know that cosine of theta is negative, is what this is saying, it's less than 0. So we should be able to figure out what quadrant we're in from this information. So we can figure out also what our tangent value is going to be equal to. But anyway, let's move on. Before we find sine of 2 theta, let's figure out our cosine value. We are definitely going to need to find our cosine value first because we go back to these identities. Sine of 2a is equal to 2 times sine of a times cosine of a. I'm going to write that down. So sine of 2 theta is equal to sine of theta cosine theta. So before we can even figure out what this is equal to, we need to find cosine theta. We have this one, but we don't have cosine theta. So let's go and find that. And the way we can find that is our Pythagorean identities. The one that states sine squared theta plus cosine squared theta is equal to 1. Okay, so we're going to say cosine. Well, we have sine, so let's plug that in. 8 over 17, square it, and then solve this for cosine. And when we solve this for cosine, we get that, let's see, remember cosine is going to be negative, so this is going to be negative 15 over 17. Y'all should know what I just did at this point right here. Shouldn't have to explain that. So we've got cosine, we've got sine, so let's use this identity to find what sine of 2 theta is equal to. Sine of 2 theta is equal to 2 times sine of theta, which is 8 over 17, this value up here, and then times cosine theta, which is this value here. So negative 15 over 17. Do the multiplication here, and what we get is, let's see, we get a big number over another big number. 240 over 289. Now, if these fractions can be reduced, I will ask you to reduce them, but this one cannot be reduced any more than what it is. So this is our sine of 2 theta, all right, one of our solutions that we're asked to find. Now, we're also asked to find cosine of 2 theta. We can go ahead and do that with the information that we have, because remember, we can use any of these three that I have listed here, that I have starred. We've got both sine and cosine values. So either way, we are going to be good on either one of those that we pick. But I am going to pick this one here. I'm going to write it down real quick. So cosine of 2 theta, this is just one of our identities, is equal to 1 minus 2 sine squared theta. Okay, so write that in. 1 minus 2, and our sine value is 8 over 17. And then square that. Do all the math on this one, figure that out. And what we end up with is 161 over 289. Okay, and there is one other. Now, what I told you before about if a problem asks you to find all three sine, cosine, and tangent of 2 theta, whoops, then do this one right here because we already found sine of 2a and cosine of 2a, so you can find tangent of 2a. So tangent of 2 theta is equal to sine of 2 theta over cosine of 2 theta, which is 240 over 289. I'm running out of room here, sorry. I'm gonna write this smaller. 161 over 289. Now, when you multiply the numerator by the reciprocal of the denominator, what happens is the 289s cancel out and you're left with 240 over 161. And sorry, this was negative, so this is negative. So now we found cosine, we found sine of 2 theta, cosine 2 theta, and now tangent of 2 theta. We are done with this problem. Here in example 2, we are going to again use our double angle identities, but this time in reverse. We're given the fact that cosine of a double angle is equal to some value that you're given, and we're asked to find sine theta, cosine theta, and tangent of theta. And also, we're given that we are in the third quadrant. So what this means is our sine value here, once we find it, it's going to end up being negative. Cosine, negative, tangent is going to be positive. Okay, so to use our double angle identities, but in reverse, let's write the double angle of cosine down. Cosine of 2 theta is equal to 1 minus 2 sine squared theta. That's just a fact. That's one of your identities right there. And what I'm going to do to find sine of theta is plug in negative 12 over 13 in here because cosine of 2 theta, that's what it's equal to, negative 12 over 13. Now, the only thing I have in here that I can solve for is sine. Solve for sine, and you have sine of theta. Okay, so subtracting both sides by 1, I get negative 25 over 13 is equal to negative 2 sine squared of theta. Okay, now divide both sides by a negative 2. When you divide both sides by a negative 2, you get positive 25 over 26 is equal to sine squared theta. Now take the square root by both sides. Remember, plus or minus here. And sine theta is equal to, now we're going to have to rationalize this thing. We get 5 over the square root of 26. And remember, this is, our sine value is negative. We've already determined that. So this in its rationalized form is negative 5 square root 26 over 26. And we're done. Now let's do the same thing. Again, using the fact that we are given that cosine of 2 theta is equal to negative 12 over 13, we can find our cosine value. Let's just use one of the other cosine double angle identities to do that with. So cosine, so we're done at this point. That's our sine value right there. Cosine of 2 theta is equal to, the other one of these is 2 cosine squared minus 1. Okay, so again, this right here is just one of our identities for cosine. And we're going to plug in again, and for cosine 2 theta, what it is equal to. And then we solve for cosine just like we solved for sine over here. So add 1 to both sides. You will get, let's see, 1/13. So let's do that, 1/13. That's equal to 2 cosine squared theta. And now divide both sides by 2. You get 1 over 26. It's equal to cosine squared. Take the square root, both sides, and we get that cosine of theta is equal to, we're going to rationalize this one again. Let's see, 1 over the square root of 26, so square root 26 over 26. And remember, we determined that cosine of theta is negative, so this is going to be negative. Okay, now we have sine and we have cosine, so it's not necessary for us to use any more double angle identities at this point. So what we're going to do to find tangent of theta is just, we know sine and cosine. So use the fact that tangent of theta is equal to sine over cosine of theta. Tangent of theta is equal to, see, sine is negative 5 square root 26 over 26. And cosine is negative square root 26 over 26. And let's see what we get here. We get, oh, this thing reduces down to tangent of theta is equal to 5. And we're done. Here's tangent. Here's cosine. Sorry, I messed up circling that. And here's sine. And that's all we're asked to find. Now, if you were asked to find, I'm pretty sure the book does, if I remember correctly, to find the secant, cosecant, and cotangent, well, at this point, that's fairly easy. The only thing you have to do is to find cosecant is take your sine value and do the reciprocal. So, flip these around. Same goes with cosine and secant. To find the secant, remember, flip these values around, and then cotangent, flip this value around too. And know that 5 is like saying 5 over 1, so cotangent would be 1/5. Okay, so that's it for this example. Now here are all of our half angle identities. And similar to how we can, we have different variations of our cosine double angle identity, we have different ones for tangent of our half angle identities. Okay, so if we're asked to use find tangent of some angle over 2, then any of these 3 you can use. Okay, it just all depends on the information you're given from the beginning on which one you want to use. Okay, so here are these identities. What I would suggest is write these on your note card and state that these are half angle identities. Same goes with the double angle identities and a couple other identities that we're going to look at here in a little bit. Okay, so half angle identities. Let's use one of them. Now, here's an example of a way that we're going to be using our half angle identities. We're going to be using them to find exact values of certain angles that were given. And this example asks us to find the exact value of sine of 22.5. And what we do here, in this case, is we're going to use our sine. And then the way we find A that goes here and here is we're going to double this angle. Okay, so let's see, 45. Now, I'm not changing much here. Sine of 45 divided by 2 is just 22.5. What we're doing here is trying to figure out what angle goes here to put in our identity to help us in finding our exact value here. Now this is equal to plus or minus the square root. Doesn't look like a square. There we go. Let me write that again. Square root of 1 minus cosine of 45 over 2. See, before we couldn't have just gone straight forward and found the exact value of sine of 22.5 with any of the identities that we have done so far. But this one right here, we know the exact value for cosine of 45, so this is the way we need to find our exact value for the sine of 22.5. Okay, so to determine whether we use plus or minus, well, we look at our original angle, 22.5. That is in the first quadrant, so everything is positive in the first quadrant. So the value of sine of 45 over 2 is going to be positive also. So use positive at this value that we're about to find. 1 minus, now cosine of 45, we should know that is the square root of 2 over 2. And then we have over 2. Now the only thing we have to do is simplify this right here. Now we are going to end up with a square root inside of a square root in our final answer. That happens a lot whenever we're solving for angles that are half of exact angles that we know of. Okay, so square root. Now to find the exact value of this to reduce what's on the inside of our radical here, I am going to say let's multiply by the least common denominator, which is 2. Whoops. I'm going to multiply both numerator and denominator by 2. And this 2 is going to distribute to both of these numbers, 1 and square root of 2 over 2. So 2 times 1, that gives me 2. 2 times the square root of 2 over 2 gives me the square root of 2. And then 2 times 2 gives me 4. Now we can take the square root of 4, because this is like saying square root of this numerator over the square root of the denominator. So we're going to say square root of 2 minus square root 2 all over the square root of 4, which is 2. And that there is our final answer for sine of 22.5 degrees. That is equal to. All right, and that's how we do it. All right, so let's take a look at this problem here. In this example, I don't like to tell y'all this, but there's a lot involved in this one. But we'll get through it, and y'all will too, on your homework. First off, we're given what cosine of s is equal to. That is the nice thing about this problem. I like being given the cosine values whenever we are finding things dealing with half angles. Let's take a look at the reason why. The reason why I say it's good to have the cosine value is because each one of these half angle identities use cosine. See that? Cosine A, cosine A, cosine A, cosine A. There you go. So that is actually a good value to be given. But if you're not given cosine of A, or cosine of an angle, it's not too hard to figure it out. Just remember your Pythagorean identity. The fact that you can find cosine of A, if you're given sine of A, you can find cosine of A. Okay, so let's look at this problem. We know cosine, that's a good value to have, but we know that this quadrant right here is quadrant 3, but we need to find what quadrant is s over 2 in, okay? And this is how we're going to do that. So s over 2 means that we are dividing our s here by 2. And when we divide s by 2, we have to divide the rest of our stuff in our inequality by 2 also. And that gets us s over 2 is between pi over 2 and 3 pi over 4. Now, if you look on your unit circle, you will see that s over 2, that is in quadrant 2 right there. This is 90 degrees, and this is some other degree. I can't remember at the moment. But that value is in quadrant 2. Okay, so s over 2 is in quadrant 2. That's some information you need if you're not given from the beginning. And now let's go ahead and use our half angle identities to find all of our trig half angles. So sine of s over 2 is equal to the plus or minus, but we already know that we're in quadrant 2, so sine is positive in quadrant 2. So I'm just going to keep it positive here and say square root of 1 minus cosine of s, trig given, is negative 3 over 7 over 2. Now reduce this right here, and let's see, what we get is the square root of 5 over 7. Yeah. I trust that y'all can do the reduction of the inside of this radical and reduce it down to square root of 5 over 7. And now rationalize this. We're going to get 5 square root 7 over 7. And I believe that's it. Yeah. Okay. Oh, sorry. 5 is in the radical, not on the outside. 35. And there we go. Now we're done. Okay, so we found sine of s over 2 That's all there is to it. And now let's find cosine of s over 2 using our half angle identity for cosine. And in quadrant 2, cosine is negative, so we need to say negative square root of 1 plus cosine of s. So 1 plus our cosine of s value is negative 3 over 7 divided by 2. Okay, so this is going to be negative, and then inside the square root, we get 2 over 7. So rationalize this. This is like saying square root of 2 over the square root of 7. That's going to be negative square root of 14 over 7. And there we go. We found cosine of s over 2. Now let's find the tangent of s over 2. And again, we could use this one right here. Since we are given cosine of a, we can plug that into this right here. Or since we found cosine of a over 2, sine of a over 2, then tangent of a over 2 is equal to sine of a over 2 divided by cosine of a over 2. Okay, we previously found sine of a over 2 and cosine of a over 2, so let's use that fact to find tangent of a over 2. Tangent s in this case, s over 2. Okay, we are in quadrant 2, and tangent is negative. Oh, well, we should know that fact anyway whenever we plug in these values. Okay, so sine over cosine, square root 35 over 7 over square root 14, that's negative, over 7. Well, when you multiply that by the reciprocal, the numerator by the denominator's reciprocal, these cancel out, and we get negative square root 35 over square root of 14. Okay, now that there can actually be reduced to this. I'm going to write tangent s over 2 is equal to negative. Now, I can write this as 35 over 14. Now, 35 over 14 reduces to 5 over 2. Now, splitting this back up, because we need to rationalize that denominator, we are going to get negative square root of 5 over the square root of 2, which is the same thing as saying negative 10 over 2. And we are done. So we got sine, cosine, and tangent of s over 2. Now on to these other two identities that I mentioned at the beginning. Like I said, we're just going to touch on these, not too much on these problems we're going to do. The problems that I assigned are actually fairly easy. It tells you to use the product to sum identities to do something, okay? So here they all are. Here's the product to sum identities. Let's do an example. Okay, so this example here uses the product to sum identity to do this. It says write 6 sine of 40 sine of 15 as a sum or difference of two functions. So we have a product of two trig functions that we want to write as a sum of two functions or difference. So using the fact that we have sine of an angle times sine of another angle, we're going to look back at this. Sine of an angle times sine of another angle. We're going to use this identity right here to break things apart. Just use our angles, what did it say? 40 and 15, in for your A and for your B. Wherever you see A in this thing, put in 40. Wherever you see B over here, put in 15. Then just subtract these two angles, subtract these, or add these two angles together, and you're done. That's all there is to using these. Okay, so on this one, I'm going to write this thing out. Let's write out that identity. Sine of A times sine of B is equal to 1/2 cosine of A minus B minus cosine of A plus B. Okay, so there is our identity. We're going to plug in, and also you start out with a 6. That just means we're going to keep the 6 on the outside here. 6 sine of 40 sine of 15 is equal to 6 times 1/2 of cosine of 40 minus 15 minus cosine of 40 plus 15. See, we just followed this identity exactly. And we're going to reduce what we can, so put together numbers that we can, like at the beginning here, 6 times 1/2, we know that's 3. And then it's multiplied to, don't even have to write a bracket, we can write parentheses here. Cosine of 40 minus 15, that's 25. So we're at cosine of 25 degrees minus, and then cosine of 40 plus 15, well, that's just 55. So right, cosine of 55 degrees. And we are done. The only other thing that we could do with this at this point is distribute this 3. So let's go ahead and do that. So 3 cosine of 25 degrees minus 3 cosine of 55. And we're done. That is all we do. Now let's look at another set of identities. Okay, the previous one was called the product to sum. This one is called the sum to product because we are adding or subtracting, in some cases, two trig functions, okay? So sine of A plus sine of B becomes this here. All right, and then you see the rest of them. So these are all of the sum to product identities that we have, and here's how we're going to use them in this next example. All right, so this problem, it says, write this given expression as a product of two functions. So that there, whenever it says write something that's being added together as a product of two functions, that should give you the clue that we are using the sum to product identity. All right, so using that, I'm going to go back here. This is the one we're going to use, this one right here, because we're adding together two cosine functions of two different angles. right, so let's say I'm going to write out that identity. Cosine of A. Okay, there it is. So following this identity exactly, we're going to plug in 3 theta in for A, and then 7 theta in for B. Let me write that out. And then say 2 cosine of 3 theta plus 7 theta over 2 times cosine of 3 theta minus 7 theta over 2. Okay, reduce down what you can. So 2 cosine of, now 3 plus 7, that's 10, but you're dividing it by 2, so that's going to be 5 theta times cosine of, this is 3 theta minus 7 theta. Well, that is, negative 4, but then you're dividing it by 2, so negative 2 theta. But remember, we're not going to write anything with negative angles in it. So at this point right here, remember your negative angle identities. You've got those on your note card, hopefully. And cosine of any angle that's negative is the same as saying the positive cosine of that angle. Okay? So to rewrite this a little bit further condensed or reduced, it's 2 cosine of 5 theta times cosine of 2 theta. And we are done. And we're done with this example, and we are actually, yep, we're done with this whole lesson. So if there were any questions, please let me know during class the next time we see each other, and we'll go over some of the problems together too. I'm pretty sure you will have some questions about these because there was a lot in this lesson, I know. So I'll see you all later. Goodbye, everybody.